Uno, dos, tres, sí. Uno, dos. Hello,
es mucho más que una conversación común y corriente. Puede ser en voz alta.
Uno, dos, tres, sí. Uno, dos, tres.
Succedesse perché hai tenuto
Okay, everybody, I think we're back, so we can start with the second part of our first day. I will leave the chair to Celeste. Muchas gracias.
Well, thank you, Karen. Thank you, everybody. For this afternoon session, we will have a few pre-recorded presentations, so you won't be able to ask questions afterwards, but if you have any questions, just you can send an email to the presenters, and they will be very willing to answer your questions. So the first one is from Dr. Swagata Chowdhury from the Indian Statistical Institute.
Hello everyone, I'm truly honored to be here today, although virtually, as we gather for this esteemed workshop. I want to start by expressing my sincere gratitude for this. Hello everyone, I'm truly honored to be here today, although virtually, as we gather for this esteemed workshop. I want to start by expressing my sincere gratitude for this opportunity to share my thoughts and insights. I must admit that I had eagerly anticipated being present in person for this event. I had my backpacks ready to face you all, but unfortunately the visa and other official complications had different plans for me. Though I had found myself on the other side of the screen, my enthusiasm remains the same. Let me introduce myself. My name is Dr. Swagat Chowdhury. I'm working as a postdoctoral research associate in ISI Kolkata. My primary research objective is reconstruction of paleoclimate with the help of different proxies like micropaleontology and geochemistry. So for today's topic, that is the benthic and the planktic foraminifera unveiling the late Holocene paleoclimatic and paleoceanographic fluctuations. So let's delve deeper into it. As we all know that the benthic forams, these are the majority which live on or within the seafloor sediment, and these are extremely sensitive to the ecological factors. Several studies have been conducted using the foraminiferal census count, especially the benthic foraminiferal census count around the globe, to understand the paleoclimatic variations and morphology of the foraminiferal test. And this morphology of this foraminiferal test is an evolutionary adaptation due to sudden or a period of their environmental changes. Therefore, these benthic foraminiferal test morphology variations can be used to reconstruct the climate changes and paleomonsoonal activity, whereas the other form, that is, they can float in the water column at various water depth, these are the planktic forams. They are the monsoon indicators, and their variations are closely linked to the seasonal reversing in the monsoonal winds and surface ocean circulations. Hence, the degree of the stratification of the upper water column offer the valuable insights into the various aspects, including the monsoon intensity and the intensity of monsoonal winds, oceanic heat budget, and dynamics of the ocean-atmosphere interaction. And all this data we are getting from the planktic foraminifera. And from benthic foraminifera, we are getting the idea about the paleo environment. So, the full overall water column can be analyzed from this both benthic and this planktic foram data. So for today's study's objective is basically three objectives we have been approaching. The first objective is to find any climatic oscillations and the faunal distributions in the Indian Ocean, especially the northwestern Bay of Bengal. The second objective of this study is to find the paleoceanographic changes during the Holocene. And the third objective of this study is to identify the influence of Indian summer monsoon on the Indian civilization. This is the map showing the location of the studied core, and this is marked by this red solid circle. The sediment samples from the NGHP hole 15A were collected for this study. The studied hole is basically situated along the eastern continental margin of India at a water depth of 926 meter. Here you can see the bathymetry map. Also, it is basically close to the Godavari river mouth in the KG basin, that is the Krishna Godavari basin. The surface circulation of the Bay of Bengal is mostly controlled by the periodically reversing monsoonal winds that drives along the East Indian coastal current. And the top 3 meter of this continuous core of this whole 15A were considered for this study to estimate the benthic foraminiferal and planctic foraminiferal populations and reconstruct the paleo-monsoonal climatic patterns. And sediments of these sections were sliced into 1 centimeter interval, and 274 samples were collected for this study. This is a pictorial representation which shows that how the foraminiferas are being extracted from this core sediment. Firstly, the samples are soaked in the water with hydrogen peroxide, and then after overnight soaking and disintegration of sediments, they are washed under the running water. Then the samples are oven dried, and the foraminifera samples are placed under the microscope, and they are seen under the microscope for identification and other census counts and other geochemical and this recorded this benthic foraminifera species what we have identified under the microscope. They are classified into different groups based on their morphology, mode of habitat, and the ecology they prefer. And on that basis, we have classified them into several groups. So here you can see the first group, which has been divided into the disoxic and oxic group, where you can see some pictorial representation, the same images of the disoxic benthic foraminifera, that is the Bolivina alata, and the oxic foraminifera, that is the Hyalina baltica. Here you can see their good preservations there within the sediments. The second group, the benthic foraminiferas, are divided into the infaunal group and epifaunal group. Infaunal, that means which forams prefer to live within the bottom sediments, and the epifaunal, that live attached to the sea surface. Here you can see some same images of the infaunal foraminifera, benthic foraminifera, that is the Bolivina pygmea, and their apertural side views are present here. And the epifaunal benthic foraminifera, that is the Civiside sculenbergi, you can see also their apertural views and their umbilical view. And the third group, based on the benthic foraminiferal morphology, that is the ABF, that means the angular asymmetric benthic foraminifera and rounded benthic foraminifera. So the angular asymmetric benthic foraminifera, you can see the Bolivina pygmea, these are the angular in size, and whereas the rounded symmetric benthic foraminifera, you can see the Civiside sculenbergi, and you can see their rounded or globular tests there. And similarly, the planctic foraminifera, they have been classified on their test morphology, their habitat, and as well as on their ecology. They have been classified into 4 assemblages for this study. Here you can see they have been divided into eutrophic and oligotrophic assemblages, as well as the cold water species and warm water species. Here you can see the eutrophic taxa, that is the Neogloboquadrinate doteri, where you can see their good same images are there, and The cold water taxa, that is the Globigerina bouloides, and their shells are very much well preserved within these sediments, and these Globigerinoides reubers are also present in our present. Now come to the one of the most important part of this study, that is the chronology. The chronology of these studied sediments has been established based on the mixed benthic foraminiferal radiocarbon isotope data. A total of 8 selected sediment samples were considered from different intervals for this date estimation purpose, which has been used using the accelerator mass spectrometry. And an age depth model was generated using the Bacon 2.2 software. This calibrated 8 AMS14C ages of the foraminiferal samples cover the total time span from 737 to 2263 calendar year BP. These ages for the rest of the samples are interpolated using these 8 calibrated ages, which cover the past 1690 years from 335 BC to 1355 AD. And these dates are already been published in our recent publication in Mohanty et al. 2023 in the Holocene Journal. In this slide, I will show you the observations what we have got from this benthic and the planktic foraminiferal data. The left panel is indicative of the benthic foraminiferal observation, whereas the right side is indicative of planktic foraminiferal observation. Here you can see that we have identified that 4 oscillating trend patterns. Okay, and this first oscillating pattern, that is from 335 BC to 406 AD, following by 406 AD to 787 AD, and then 787 AD to 1202 AD, and 1202 AD to 1305 AD. So we are getting the last 1690 years sediment history from these sediments on the temporal variation of this benthic as well as from this planktic foramen. Now just look into the first and the third phases that is marked by this white background here in benthic data as well as in the planktic data. You can see that this first and the third phase, that is characterized by the consistent abundance with the rising trend of the RSBF epiphonal as well as the oxic groups, whereas the relative abundance of the AABF and the inphonal and disoxic groups that shows gradual decreasing trend. Studies showed that a relative high abundance of RSBF is characterized by the high energy, well oxygenated and low saline water. And this interval here for this planktic data, you can see that there is an increasing abundance of this oligotropic taxa and decreasing abundance of this eutropic taxa, as well as this from this planktic data, it indicates that during this period there is a low productivity and the water was strongly stratified, and which can be attributed to the intensified southwestern monsoon precipitation as well as the increased runoff from the continent. Now come to the second and the fourth phase, that is marked by this blue background. Here you can see the increasing trend of the ABF, inphonal and as well as the disoxic groups, and the decreasing trend of RSBF, epiphonal and the oxic groups that demonstrates the weak ISM conditions. Therefore, there is a chance of less precipitation during this period. The predominance of the inphonal taxa and disoxic species point to a low oxygen microhabitat with a decrease in soluble oxygen concentration in the sediments. According to the various researchers, the prevalence of the ABF, which indicates less oxygenated, low energy, colder and hypersaline environment. On the other hand, from the planktic foraminiferal data, you can see the increasing abundance of the eutropic taxa and the decreasing abundance of the oligotrophic taxa. It suggests that there is a high surface productivity which is associated with the nutrient supply to the surface water through vigorous vertical mixing, and it indicates that these two phases that is marked by this blue background, that it indicative of cooling phase prevailed during that time. Besides, we have tried to emphasize the climate roles in the prominent phases interlinked with the cultural growth in the Indian subcontinent during the late Holocene period. The strong ISM induced precipitation made this agriculture a primary source of the revenue during this period. In addition, the highly productive environment helped in growth of the trade and promoted the cultural dynamism. The last part of these first phases, what I have already mentioned, you can see it coincides in the starting and the growth stage of the Gupta dynasty in the Indian subcontinent, and you can see the great emperor, the flourished with thriving arts, literature and science. This might be influenced by the favorable climatic condition induced by the strong ISM, and this heavy precipitation triggered the huge crop production and artificial water storage system. Dams were built, and thus the irrigations and the overall economic growth of this time is being helped by this strong ISM, and it helped the Gupta emperor to rule over a largest part of the Indian subcontinent. And you can see during the third phase of our study, that is here, the Indian economy flourished due to the heavy rainfall and excellent crop production. However, a persistent drought destroyed the socio-economic background of the Central Asia at the end of this period during that time. Therefore, India faced several invasions from the Central Asian rulers like the Mahmud of Ghazni and Muhammad Ghori, who plundered the rich wealth of India, and that indicates that the climate and the ISM variability strongly influenced the India's socio-economic activity in the past. Here we have compared our benthic and planktic foraminiferal data with several regional global paleoclimatic archives to identify the ages of various climatic events. As I have already mentioned, that we identified 4 oscillating trend patterns from this foraminiferal data, and we have identified 4 stages. And here we have identified 2 alternative warm phases marked by this orange color box, that is linked with Roman warm period, and followingly the medieval warm period. At that time, the ISM intensity was very much high, whereas this blue box, that is indicative of the cold phases and which are linked with the global phenomena, that is the dark age cold period and medieval warm period to little ices transition period. And at that time the intensity of the ISM was low, and that is indicative of the cooling phases. So these are the conclusions which we have got from this study. This high resolution 14C AMS dating recorded the climatic events from 335 BC to 1355 AD, that is the last 1690 years of the late Holocene period. The second observation, we have found that these benthic and the planktic foraminiferal taxa, these are strongly influenced by the changes in the oxygen concentration and other environmental factors. And the studied sediments, they have recorded the signatures of the Roman warm period, dark age cold period, medieval warm period, and the transition between the MWP and LIA. And conclusively, we can tell that this combined study of benthic and planktic foraminifera is a more robust proxy for paleoclimatic reconstruction and ocean hydrography modeling. And finally, what we have linked to it, that is the role of ISM on the growth of the Indian civilization, that is the strengthening and the weakening of the ISM directly control the socio-economic growth and the Indian civilization stability. As I am concluding this presentation, I want to introduce with my lab members and the Micropaleontological Laboratory of IIT ISM Dhanbad, who have contributed immensely to the Indian as well as the global scientific community for this type of successful research endeavors. I would like to extend an invitation for any questions or clarifications you may have. Please feel free to ask me, just drop me an email at your convenience. I am very much happy to answer you all. And thank you for your attention and engagement throughout this presentation. I look forward to further discussions and collaborations in the future. Thank you all.
Well, as you hear, he will be happy to take any questions by email, so you are more welcome to grab him. So now our second speaker of the afternoon will be Maria Isabel Sandoval from the University of Costa Rica.
Hello everyone, I'm Maria Isabel Sandoval I am associate professor here at the Geological School. So we'll give you some of the results and the preliminary results that we have from the Central Pacific of Costa Rica using the deep marine sediments. So we are working in a multidisciplinary study in collaboration with some of my colleagues that are here. There, Stephanie, Viviana, Max, and Jorge Cortez, and some other from CIMAR also. So next, please. Where is the, sorry. So the idea of this study was to characterize geologically the sediments from the Pacific coast coming from the slope that were from some deep marine sediments from the slope until the Cocos Island. I will show you in the next slide. But the idea was to work principally of marine and to compare with fluvial sediments too. So with these sediments, we work with a geomechanical model, mineralogy, biogenical and geochemical composition, and chronology. I will talk with those topics in this presentation, and geochemistry will be in the future. So the idea is to know the age of those sediments, also to see the composition in general, and then to reconstruct and to see the geological history, the recent history, the Holocene. Next. Okay, so the location of the samples. Jorge, in the first presentation of this morning, he gave a talk about this region. This is the Central Pacific of Costa Rica. So we have different samples, different push cores from different expeditions. So all the cores are coming from the slope here. Also we have from Osa Peninsula, but this is another study that we have. We have a poster, so we can you can take the details of this study in the poster. And also we have a poster with the detail of one of the study here regarding the radiolarian specifically. So these samples we have from the slope, as Jorge explained you, there is some methancysts here. We have the seamounts, around here. So we have different, that was the idea, to compare and to see what is going on regarding the geological composition in general. So I will give you the detail of 2 samples of 2 cores, because we have lots of them. We have more than 40 cores, but those cores are coming from, for example, this one from the slope. As you can see, we have 400 meter depth approximately, and in this one we have around 1,000 meters depth. So as also Jorge explained you, these expeditions or the cores were taken from 2 previous expeditions, from the Atlantis and from Falkor in 2018. And the fluvial deposits, the sample from fluvial deposits was also kind of push cores, but we're taking kayaking or taking a boat and going to the rivers. So we are still working on that. So I will not present you results from the fluvial deposits. So the methodology, this is the core. This is the push cores. The push cores were frozen in the expedition and taken to the lab here at the university. Then they are cut, and that we were analyzing is to studying small samples, each 3 centimeters approximately, to see the variability of the minerals, and also from the biogenical composition regarding radiolarians in this case. And also we will be working on foraminifera in the future. So what else here? Okay, so for the mineralogy, we have different methods. We started doing smear slides to do the counting. And for example, in general, in the slope, as I told you in this, we will talk about these 2 samples, the green started slope. So we have principally silicates, clays, for example, hornblende, microcline that we have in here in the photo. And this is a type of plagioclase, biotite here, for example, and calcite and biogenic content. So we are doing the counting, more or less 300 grains or 400 grains in the smear slides to see the variability through time. And also in this abyssal plain that we have is principally pelagic organisms. So planktonic foraminifera are very abundant. And also we have coccolith and radiolarians and diatoms also. So principally we have calcite. When we analyze XRD, we also do, this is a part of the methodology that was almost finished here. So we have, as I told you, in the green, in the slope, we have plenty of silicates and coming from the tephras or from volcanic eruptions and from the rivers also, but here we are just almost having calcite and some plagioclase also from the seamounts, for example. So yes, so other analysis that we made was EDX. This was an SEM that count, or is an automatized counting that counts the particle and takes in each particle, gives the composition of each particle. So each one of these lines here is one particle, and give you the detail of the composition, elementary composition. So in red we have the abundance, the more abundant, and in the slope, as you see, we have also calcium, silicates, but in this specific example we have a lot of iron and sulfur indicating pyrite. This is related with the methancepts, this sample. And in this sample, for example, in the abyssal plain, we mostly have calcium carbonate and silicate, indicating biogenic composition principally. So this is was the idea regarding the mineralogy. So for the biogenic composition study, principally that we were counting in general, but was the siliceous content, but also ways, as I show you, is principally calcites using they are mostly foraminifers, but here we destroy the foraminifers to see the siliceous content and to see what's happened with the diatoms and radiolarians. In this study, Alexis, as an undergraduate student that is here, so he analyzed he analyzed the taxonomy of radiolarians from the first time in Costa Rica. We didn't have a catalog or a description of the species that we have from the recent radiolarians. So mostly we have fossils using radiolarites so that was very useful because we didn't have that before. So now we can continue doing more paleoceanographic studies using this list or catalog of species. So the poster is, the catalog is in the poster session. So I invite you to take a look at that. So as you know, this area, the Eastern Pacific Equatorial, is very successful regarding the bioproductivity and productivity using radiolarians and diatoms. So here, as you see, we have very successful counting, for example, 289 in the samples, regarding the sample from 0 to 15. And then we also have radiolarians, plenty of radiolarians. This one of the most successful samples, this more than 1,000. Yeah. So this is in the abyssal plain. So for the taxonomy of radiolarians, we have around, well, Spumelaria is the principal order that we have. We have 42 species from Spumelaria and 34 species of Nacellaria and some collodarians. So just to let you take a look, we do SEM, also images, and also we were counting that using the microscope, the normal microscope. And well, so Viviana started doing the foraminifera with some samples. And for now, that we have is principally Globorotaria menardi in the samples. This is abundant in foraminifera, and also Neoglobocadrina dutertrei. This is increasing also in some samples, so we can, in more detail, we can take a look if we can see some Niño conditions or La Niña conditions through time. Also, regarding geomechanics of the sediments, so principally that we do is, okay, that what we have is deeper is finer. We have finer the grains. So we have more fines, we have some sands. This sand is not, it's principally the foraminifers, that this is sand, and also some gravels. And some of the taste porosity is very high in the samples. And regarding the age of the sediments, we do some radiocarbon in 2 cores. So for this, for the Quepos Plateau, that is the closer to the slope, but it's not in the slope because the slope, it doesn't work doing the radiocarbon because it's very reworked. So we use principally, the closest that we have from the slope is 144 centimeter in 1,000 years. And then we have an increasing of 70 centimeters in 1,000 years. This was interpolated. And in seamount 8, and that is in the abyssal plain, that we have 0.29 centimeter in 1,000 years. And then increase 1.12 in 1,000 years. So thank you for your attention. If you have any question.
Hello, still me. I want to ask for the chronostratigraphy, can you use the tephrostratigraphy in this area?
We didn't have a record of tephras in the sediments. So, but we can, if we have longer cores, we can do that. But in this, it's just 20 centimeters. So
Too shallow?
it's too shallow, yeah.
Okay.
Very interesting presentation. I wanted to ask you about, what about coccoliths? Have you done analysis on them?
Yeah, we sent some sample to study the coccoliths in Colombia because we don't have a specialist here. But yeah, we'll see. Mm-hmm.
Thank you.
Any additional questions?
Thank you, Maria. Do you have a rough idea about what changes the sedimentation rate on those two cores?
For I will say that this one that is close to the slope, it could be like a turbidite or something like that. Yeah. And the other one could be a change in the productivity, just because it's just pelagic organisms. Yeah.
Do we have questions from Zoom? No?
Okay, thank you.
Thank you, Maria. The next talk is also a pre-recorder presentation, and it's from Amose Hajam from the Central University of Kerala.
Good evening, all. I am Good evening, all. I am Amus. I am a PhD student from the Department of Geology, Central University of Kerala. So today I'll be mainly discussing about the stable isotope geochemistry of globogenerates morphotypes. So I'll be mainly trying to answer if there is an offset in delta 18O and delta 13C of coeval SSSL morphotypes of Georuba in the northeastern Indian Ocean. So coming to the introduction, as you all may know, that Georuba is a commonly found mixed-layer species, plankton species that's widely abundant in the tropical and subtropical oceans, and it is commonly used as a proxy to reconstruct past variability in sea surface temperatures and also the stable oxygen isotope composition of seawater. So there are like two morphotypes of Georuba that was identified, and the first one is Georuba sensu stricto, represented as SS, and the other one is the Georuba sensu lato, that is represented as SL morphotype. So comparing these two morphotypes, the SS morphotype is having more symmetrical chambers in its final wall that increases moderately in size, and it is also symmetrical over the previous sutures. On the other hand, the SL morphotype is somewhat having asymmetrical chambers, especially the final chamber being either platy or elongated, and these chambers are asymmetrical over the previous sutures. So several studies have suggested that there are like differences in its geochemistry, that is delta 18O and delta 13C, and also the trace elemental ratios like NGCA, and these differences in its geochemistry may be due to the seasonal preferences, like the SL is being identified as a cold or winter biased species according to some studies, and also maybe due to their distinct calcification depth habitat. So some studies have suggested that the SS and SL lives in separate water depths, like SS calcifies in the upper 25 meter of the mixed layer, while SL is inhabiting in much lower depths within the mixed layer, like 25 to 50 meter of the water column. So contrary to this, there is a recent study from the Gulf of Mexico that they have observed that there is no systematic or significant offsets in coeval SSSL delta 18O and delta 13C. However, there are some studies that support the depth or seasonal allometry within these morphotypes. So depending on the oceanographic settings, this habitat preferences of these two morphotypes could vary regionally. However, there is no such study conducted in the northern Indian Ocean. So in this context, we focus on distinguishing the SSSL geochemical variability using individual foraminiferal analysis, that is IFA, of a stable oxygen and carbon isotopes across a substantial number of individuals. So IFA is a new approach in which we measure the oxygen or carbon stable isotopes in individual specimens of Planctiforaminifera, and in this case, we measure this, we take the measurements on SS and SL species. So coming to the study area, so northeastern Indian Ocean has a unique hydrography in terms of this huge freshwater runoff that is mainly coming from the northern Indian rivers like Ganges, Brahmaputra, and also rivers originating from the Indo-Bourbon ranges like Airavati and Salvi. And there are also contributions from minor rivers like Mahanadi, Godavari, and Krishna into the Bay of Bengal. So this huge freshwater runoff, it means the northern Bay of Bengal, the sea surface salinity is much reduced over the northern Bay of Bengal when compared to the southern Bay of Bengal and even the Arabian Sea, which is having a higher sea surface salinity. And the surface currents, it also plays an important role in the cross-basinal water mass exchange between the Arabian Sea and the Bay of Bengal via the Gulf of Mannar. So during the summer months, the East India coastal current, it will carry the high salinity waters of the Arabian Sea towards the Bay of Bengal via Gulf of Mannar, and during winter, this surface current reverses that in such a way that the West India coastal current, it brings the low salinity water from the Bay of Bengal towards the Arabian Sea. So in this study, we have used 3 cores, two is from the northern Bay of Bengal, one is from the northern and one is from the eastern Bay of Bengal, and one of the core is from the Gulf of Mannar. So these latitude and longitude and the water depth in which the cores was collected has been represented here. So we have used the core top and late Holocene samples in all of this from all of this core. So coming to the methodology, so we did the individual foraminiferal analysis. For that, we selected approximately 60 specimens of G2 by SS and G2 by SL each from the core top and late Holocene sediment samples for stable oxygen and carbon isotopic analysis. And then during the analysis, we have cleaned the individual samples with methanol, and later these measurements were taken using a thermoscientific MAT 253 plus IRMS, which is coupled to a Keel for carbonate device, which is housed in the Paley Square laboratory at the University of Arizona. And the size fraction we have collected, we picked the samples from a size fraction of 300 to 425 micrometer, and a total of 362 IFA measurements were taken, each for delta 18O and delta 13C of SS and SL species. So coming to the results and discussion, this plate, it represents the SEM images of SS and SL morphotype. The first 2 columns, it represents the SS morphotype, and the last 2 columns, it represents the G2 SL morphotype. So in this table, we have given all the mean and standard deviation of SSSL, stable oxygen and carbon isotope measurements in each of these three cores. And we can see that the delta 18O values were much more negative in the Bay of Bengal when compared to the Gulf of Mana core. And this may be due to the freshwater influence and the resultant salinity changes in the northern Bay of Bengal when compared to the Gulf of Mana core. And we also plotted the regression analysis of delta 18O and delta 13C of SS, and the same with SL. So the SS is represented in orange colored circles and SL is represented in cyan squares. So we found there is no correlation between the delta 13C and delta 18O of SS and SL morphotypes in all of these three core sites. We also did a statistical analysis t-test, and the null hypothesis is that there is no significant differences in the delta 18O and delta 13C values of SSSL morphotypes. And if the reported p-value is greater than 0.05, we retain the null hypothesis. So you can see in the table, we got almost in every values, that is the p-value is all greater than 0.05, which means that we can retain the null hypothesis and there is no significant differences in delta 18O and delta 13C values of SSSL morphotypes. So we also plotted the histograms plotting the delta 13C and delta 18O versus frequency in all of the three cores. And so the concept is that the previous studies that is based on sediment traps and surface sediments, we have hypothesized that there is seasonal or depth allometry within SSSL morphotype. So this inference is based on the discrepancies observed in stable isotopic and trace element measurements of the morphotypes despite the limited number of samples. However, if this is the case, we would expect that the delta 18O and delta 13C values should be different for each of these two morphotypes. But however, in all the in all of these histogram, bar diagrams, we found that there is no differences in its delta, in the coeval SSSL delta 13C and delta 18O. And also, if the SL is calcifying in a deeper depth, we would expect that it should have a higher delta 18O values compared to the SS, and we didn't observe that too in this plots. So coming to the conclusion, our observations and statistical approach confirm that there are no significant offset in delta 18O and delta 13C of coeval SSSL morphotypes of G-Dubai in the northeastern Indian Ocean, and the mean delta 18O values of both SS and SL exhibit more negative values in the Bay of Bengal when compared to the Gulf of Mana. This is because of the impact of freshwater runoff into the northern bay and the resulting salinity changes in the upper water column. So the take-home message is that we suggest no biases for the use of non-selective mixtures of G-Dubai for the paleoceanographic reconstructions in the Indian Ocean, at least for Holocene samples or for periods with similar biogeochemical and oceanographic conditions allowing for G-Dubai morphotypes to calcify within the same ambient waters. So I would like to thank Dr. Kaustubh Tirumale and Dr. Lee Vetter from the University of Arizona, and also my advisor, Dr. Sesión from the Central University of Kerala, and also Dr. John Kurian from the NCPR Goa for providing us with sediment core samples. And I would also like to thank my research funding from the Department of Science and Technology, the Government of India, and also the Fulbright Commission in India and the US. So thank you all for listening. And if you have any questions or suggestions, please do email me. Thank you. Thank you all.
Thank you. So we have now our third keynote speaker of this symposium, Dr. Isabel Cacho. She is a full professor at the University of Barcelona, geologist specialized in the research of past climate variability and associated changes in the ocean. Her research is based on the application of several geochemical tools on deep marine sediments and cave speleothems. That's a word that I just learned today, actually. She has a long experience studying the impacts of past rapid climate variability in the Mediterranean region, being pioneer in establishing its connection with North Atlantic circulation. So thank you very much, Dr. Cascio, for being here, and we will be very kind to listen to your talk.
Now it's working? Yes. Thanks very much. I want to thank particularly to the organization for inviting me to come. It's my very first time here in Costa Rica. I'm very pleased to be here. And so it was a very good excuse to come to this country and visit you. So today I'm going to present you some results coming mostly from a project, European project, a ERC grant devoted to devoted to analyze changes in the past circulation of the Mediterranean Sea. But I will try mostly to strengthen the approach using different geochemical proxies. We have been, during this session, we have been listening to different approaches using mostly, not only, but mostly different taxonomical associations. And now I'm going to present results coming from chemistry. Sorry. Yes, let's see. And also, I saw that this program, this Inqua project, is interested in these connections, remote regions connections, sensitive to changes. And I think that the Mediterranean is a good example, since it's settled within these north high latitudes and low latitude systems, sets within these storm tracks from the high latitudes and these high pressures areas from the low latitudes and the ITC set. So it's sensitive to the migration of these two different systems, and so sets right in the position to this interaction within these remote latitude systems. Okay. So I will start trying to explain a bit basics on the Mediterranean circulation for those which are not familiar. This diagram here represents the whole Mediterranean. Here we will have the two main basins, the Eastern Mediterranean Basin, and here will be the Western Mediterranean Basin. Will be the Strait of Sicily, and here we'll have the Strait of Gibraltar, which connects to the Atlantic Ocean. So circulation in the Mediterranean is formed by the entrance of relatively low salinity waters coming from the Atlantic, and these waters progressively change its properties until they become saltier but denser, and they end forming intermediate waters, which will be represented by these Levantine intermediate waters, which fill the intermediate depths of the Mediterranean. And also there are other parts of the Mediterranean where this form deep water masses, one which is the Eastern Mediterranean deep water mass, and the other is the Western Mediterranean deep water mass. At the end, these intermediate water masses and deep water masses mix to form the Mediterranean outflow water, which goes into the Atlantic, in some way is a contributor of this global circulation system from the North Atlantic Ocean. So properties of these water masses are controlled by the climate conditions, and the situation is that the Mediterranean is a relatively arid basin. So it makes it a concentration basin of what is called, it means that evaporation is higher than the sum of precipitation and river runoff. So that makes the Mediterranean particularly salty, and that makes this outflow of denser waters coming in depth. And here we have a similar picture, but representing the salinities. We can see the higher salinities occur to be in the water masses formed in the Eastern Mediterranean Sea. Okay. The motivations to look to this circulation system is because it's particularly sensitive to climate. So changes in the circulation is going to reflect changes in the past times of climate. And here we can look to actually recent conditions. Here we have a study from the last few years based in instrumental data, where we can see in a TS diagram how the water masses have changed properties going towards saltier values, but also warmer in the last few years. So changes, the current climate change is already transferring to the interior of the Mediterranean, and it has actually, this represents the Gibraltar Strait. These changes in the properties has already been translated to the deep basin. So we can see that very rapidly these changes in climate are transferred to the interior of the Mediterranean. But it's not clear. There are some predictions, future projections, trying to predict what will happen by the end of the century in the current conditions of climate change. And this prediction said that these changes that lower salinity, higher salinity but lower temperature, higher salinity and higher temperature, is going to cause a decrease in this thermal circulation system. It's going to become weaker. But as I mentioned before, the circulation system is the water masses forming the interior of the Mediterranean are formed in different basins. I didn't mention actually the basins, but the intermediate water occurs in the Levantine Basin. The deep Eastern Mediterranean water occurs sometimes in the Aegean Sea and mostly in the Adriatic Sea. And the western one happens to be in the Gulf of Lyons. So when these model projections look to the individual basins, it doesn't seem to be the same for each of the basins. It changes depending on the basin, the projections. The motivation for me was trying to see in the past time, when we know that different climate changes have occurred with different forcings, how these individual basins, cells or individual water masses have changed through these different climate conditions. So this will be a bit the questions to be addressed. What is actually the natural variability of this climatic system? What are the forces controlling the changes in the individual basins? And how is the reaction of this? What is the reaction and the connection within the different water cells? So these are questions which remain open, and I'm not going to answer to that. But today I'm going to try to answer some of them. I will go later to this. I'm going to focus mostly in the deglaciation and the Holocene period. And I'm going to introduce a bit some changes that we already knew that occur in each of these basins. We start with the the Western Basin. In the Western Basin, along the deglaciation, here we have two isotopic records. Here will be the deglaciation. We have a period of time where we have the formation of organic-rich layer. Rich material, organic matter. At that time, deep currents is this proxy of grand size, which indicates deep currents are weak. We know that at that moment, this deep formation in the Gulf of Lyons was weaker. On the other side, we know that in the Eastern Mediterranean Sea also happens a period of stagnation very well known as the last subpropel, the S1 subpropel, when there's also accumulation of organic matter. Here is represented with this barium iron record. Actually, here the conditions arrive to be not only disoxic, but anoxic conditions. So that has two phases. And here, actually, we can also, this is a record which is from the same core that Laura presented this morning, but this is a core of grand size, which indicates less water formation in this moment from the Adriatic Sea. Well, as you can see, this organic matter, largest high organic matter, happens to be later of this organic ridge layer. Here we already are in the Holocene period, where here we are in the deglaciation. So one of the motivations, one of our motivations was trying to investigate the relationship within these two events. I'm going to show you now results coming from three different proxies. Three different proxies which try in different way look at this question, how we can learn about changes in the past circulation. And these, all three proxies or methods are geochemical, but are very much related to organisms. Here, I'm going to show you records, the most from oxygen content, based in a proxy of uranium-manganese ratio measured on the coating over these foraminifer tests. I have to say that you have saw during this morning, we have seen few benthic records, very sensitive to oxygen changes. And I have to say that we are working very much trying to compare and relate this proxy with benthic foraminifera assemblages. And it did work very well. I'm not going to show you today results on these benthic assemblages, but I have to tell you that indeed they really fit very well what is observed with the benthic foraminifers and with this geochemical proxy. The good thing is that when benthic foraminifers disappear because it's too anoxic, the event, we can still measure uranium manganese. So that's the good thing of this, about this proxy. Also, it's faster than benthic assemblages. The other proxy I'm going to use is the neodymium isotopes measured on the crust and the diagenetic cross of foraminifer test as well. And this I will explain better later, but it's going to tell us about the source of a water mass. And the final proxy, I will show you some results, are coming from the paired use of two different dating approaches, which is carbon-14 and uranium-thorium measurements on coral remains, and also on a combination of planktonic and benthic foraminifera. This proxy is going to tell us about the residence times of a water mass inside the ocean. So in some way are independent proxies that they tell different environmental variables, but all of these variables are controlled by changes in the circulation. So in that way, we are trying to understand what happens. We have know a bit more, know the whole picture. So I'm going to start with the oxygen, with the oxygen proxy. And first of all, I would like to show you this data recovered in a cruise we produced, Transmon cruise in 2021. And here we have a transit coming from this part of the Mediterranean and going to the Atlantic Ocean. So, as you say, it's not north, south, or east, west. This is Mediterranean, this is Gibraltar, and this will be the Portuguese margin and the North Iberia margin. Okay? And what is represented here is the oxygen content. And what we can see is strong changes, and in some way we can observe that these water masses, which is the Levantine intermediate water formed in the Eastern Mediterranean Sea, can be discriminated from the water masses formed in the Western Mediterranean Sea with lower oxygen content. And with these water masses go into the Atlantic Ocean can be also discriminated by the oxygen content. So looking to the oxygen content, we want to in some way see how this current picture has changed in the past time. Also, I wanted to mention that these are also recent data from instrumental results coming from the Mediterranean Sea, where is plotted here the oxygen content in relation with the salinity and the temperature. Oxygen is in color, and what we observe is changes in what we observe that different water masses are related to different oxygen contents, but also what we observe here are oxygen content different years in this area of the Mediterranean Sea, and we can observe that when we have a deep convection event, a strong one, oxygen content changes. It's an increase of oxygen in the deep ocean. So we can see that oxygen, again, is a good proxy of how the ocean conditions, current conditions are occurring. So now I'm going to tell you a bit more on the proxy. The proxy, this uranium-manganese ratio, works because uranium and manganese have an opposite behavior in front of the oxygen conditions. When we have low oxygen conditions, uranium is insoluble, and manganese is soluble. So when we have a coating over our foraminifers, we have higher uranium when we have less oxygen. So we are actually measuring uranium-manganese ratio over this coating of the foraminifera. Here we have a attempt of calibration based on some data that we have produced in orange and some data from the literature, and we can observe that there is an exponential relationship within the oxygen content in waters and the uranium-manganese. It's not perfect, so it's not actually quantitative proxy, but I think it's, we consider it a good qualitative and semi-quantitative proxy. So now I'm going to start to show you results of this proxy, of this uranium manganese, and I'm going to start with the Western Mediterranean Sea. As I mentioned before, we are going to see for the last deglaciation and Holocene, and I'm going to plot next here a series of records which are uranium manganese coming from cores at different depths. So we are going to try to go through this oxygen minimum zone. It's not actually, it's a low oxygen zone at the moment. It's not a minimum zone. It's not so low, the oxygen at the moment. But we will see what happens in the past time. And here we have this indicator of the organic rich layer as mentioned before. I will try to go a bit fast for this. We see indeed increases of this uranium manganese proxy at the time of this organic rich layer. We are looking to data from these two deeper sites, but we will observe that the very deep one was always relatively well oxygenated. Here is where the oxygenation was worse, but it's not exactly the same time of the organic rich layer. I'm going to keep going up to the cores at the top. We see that actually this core here has even less oxygen content and happens to be actually reventilated far before the end of the organic rich layer. And if it continues going up, we have this other core with comparable values, with very low oxygen at the end of the glacial. It will be Heinrich 1, and this will be Bolin-Alerot. But the younger dryas is different what happens in this intermediate core and this. In this, oxygen reventilates, while the younger dryas here in this other core is still low oxygen. We are going to go upward to this other core here, and we observe a very similar behavior than the other one in here. We keep with this very low oxygen. And right after the organic rich layer, or just before, we have a ventilation here, which happens to be during the sapropel one. This band here is the sapropel, and then conditions get a bit worse on oxygen in this upper part, but not in the others. So actually, these low oxygen conditions is more the story is telling about this intermediate water and not so much about the deep water mass. The deep water mass most of the time is relatively well oxygenated, but what is telling that this minimum oxygen low conditions during the glacial, the deglaciation really was enhanced, really was very pure oxygenated area, was an oxygen minimum zone, very intermediate, reaching below 900 meters. But then younger dryas ventilated intermediate waters, but shallow waters, they were still low on oxygen, and only when the sapropel arrives get ventilated. We are going to try well, here I'm trying to summarize this situation. We have a very expanded oxygen minimum zone during the Heinrich 1 and Bolin-Allerod, which during the younger dryas get reduced, well ventilated this area. During the sapropel one was minimum, and then expand a bit in the upper part after the sapropel one. So that would be the evolution. Was a bit of surprise because we were considering that this stagnation was coming from the deep water. It's actually a story coming from the Eastern Mediterranean Sea. Now I'm going to look to, this is the same data I have shown you just at a moment. And now I'm going to show you here results coming from the Eastern Mediterranean Sea. Actually from the same core that Laura showed before. And actually another core from the Adriatic Sea. So these are in orange. We can see really that here is the sapropel, here is the organic rich layer. Actually values are very comparable. They are all of them with the same scale. So really we were talking about a very low oxygen contents in the intermediate western waters. And what we observe is really when one basin becomes anoxic, the other become well ventilated. Really, it's a sort of seesaw coming within the two basins. Now I'm going to jump to the other proxy I've mentioned before, which is the neodymium isotopes. Here I show you an image of the lab. We are very proud. A big effort of the last few years has been to set up this new laboratory for radiogenic isotopes. So I'm going to show you now results from neodymium inframinifera, but we can also measure strontium, lead, neodymium and interreginous sediments to see the source of the sediments, boron in the foraminifero for paleosalinity, for carbon, for acidification, for pH. We are setting up now the uranium thorium for dating. But now I'm going to show you results of the neodymium that we can measure in waters, and I'm going to show you results from a cruise from the uranium, with the uranium actually. It was a cruise coming from the Eastern Mediterranean to the Western Mediterranean Sea. And since the geology of the Eastern Mediterranean and the Western Mediterranean is very different, the geology transferred the signal to the water masses. So water masses formed in the Eastern Mediterranean Sea have a neodymium signature very different to those water masses formed in the Western. And we can see here this comparison for this central part of the Mediterranean, where here we have the salinity. I showed you before that the Eastern Mediterranean have higher salinity, and here we can see the waters coming from the Eastern Mediterranean with higher salinity. And here we can see these same waters, but with neodymium, with the neodymium isotopes. So we can we tested and we showed that we can reconstruct the current oceanography of the Mediterranean Sea based in neodymium isotopes, measuring them in waters. And then the next step was trying it in the deep core. Now I'm going to show results coming from a core close to the Sicilian Channel. In the western side, close to the southern part of the Tyrrhenian Sea, is this core located here. And what we measure here are these neodymium isotopes, but here is transfer to Eastern Mediterranean source water percentages. What means? When we have higher values here, means more water coming from the eastern basin. When we have lower values here, means less water coming from the eastern basin. So at this location, this point here is monitoring this exit of water coming from the Levantine intermediate water, but also deep water from the Eastern Mediterranean Sea. And what we observe here is strong changes in this outflow related to the younger dryas. It was a big surprise. We were not actually looking for that, but we found it. And of course, that was expected and was what we were looking for. It's a strong decrease of this outflow during the sapropel one. It was, has been announced several times. It was, we were expected, but it was the very first time that we could measure in a quantitative way this reduction of transfer coming from water from the Eastern Basin. This was this year published with Sergi Trias Navarro and co-authors, which was a PhD student and was recently published, and we could estimate the relative percentage of this contribution. So what was a big surprise, was this increase, major increase during the younger dryas. I mentioned before it was not expected, and that means that really changes in the AMOC at this time changed the climate conditions in the Eastern Mediterranean, making a more intense convection. If we go back to my previous story before, which was data from the Alboran Sea, which are these records. Here you have the records before, those are 900 meters. And we observe that the moment that ventilates is right at the moment when we have this neodymium anomaly. This is the record I just showed you from the Sicily Channel. So this major outflow coming from the eastern is actually controlling this change. We interpret that is controlling this change in the ventilation of intermediate waters. I have also added here a record coming from the from the Gulf of Cadiz, which indicates a strength of the MOW, of the water, of the Mediterranean water mass flowing into the Atlantic. And we see that the major increase happens to be right at that moment. So it's telling us that really changes in the Eastern Mediterranean Sea is controlling very much changes in the Western, but also is controlling what is going on through the exit of the Strait of Gibraltar. So here, something else. Oh, yes. Yes, that was to locate the different records at different depths, okay? So this is outside the Mediterranean here. Here is the Alboran Sea, and this one is the one in the Sicily Channel that we've said before. We are going to bit complicate. Okay, it's time. We are going to the last proxy I announced, which is the deep coral, based in deep coral measurements and also foraminifera measurements, but foraminiferas coming from a deep coral seamount. And what is the value of that? The value is that from one side, deep corals can be dated using two methods, two independent methods, uranium-thorium and carbon-14. Uranium-thorium actually is providing us the actual dates, the calendar ages, but carbon-14 not. Because carbon-14 enters in the carbon cycle. Enters in the carbon cycle, it means that depending on the circulation, this age can be longer. If this water mass stays longer in the Mediterranean, it's going to get older ages. If you have more ventilation and this water mass is younger because it has been in contact recently with the atmosphere, it's going to be younger dates. So the dates of these corals, of the carbon-14 dates, is going to depend on the time that this water mass is inside the Mediterranean Sea. So using these two proxies, uranium-thorium and carbon-14, we can extract the anomaly of the carbon-14 relating to the circulation and see whether this water mass in the Mediterranean stays longer time or shorter time. This approach can be also done combining plantic foraminifera and benthic foraminifera. We can date planktonic foraminifera, which are closer to the surface, so they are more in equilibrium. They are not in equilibrium, but they are closer to the equilibrium with the atmosphere. The benthics should be less in equilibrium. It's longer, so it's going to be a difference. But the longer time residence of this water mass will provide a larger difference. And when we can also locate these planktonics in absolute ages using other approaches of tuning usually, so we can also measure the reservoir age of these surface waters. So we have two different strategies, one based in the deep corals and the other based in the combination of plantic and benthic foraminifera, trying to estimate reservoir ages of the water masses. So let's go into the results, and I'm going to show results coming from a couple of seamounts in the Alboran Sea, where are formed by deep sea corals. And there is appearance and disappearance of corals for different reasons. And here we have a summary of potential causes of this development or not development of these deep sea corals, different variables, which are not clear which one of them were controlling these changes. Here we have the same period. In red, this is the record coming from the Gulf of Gulf of Cadiz, where we have this maximum speed during the younger dryas. And what we want to show you is these deep corals, they have a very high development or growth during the Bolinaleros before the younger dryas. Right at the younger dryas, they almost disappear. There is very little appearance of these corals. And then after that, in the Holocene, they are very happy developing. Even during the beginning of the sapropel, they develop very well, and they disappear for the second half of the sapropel. So here we have our changes in the reservoir, the ages. The ones measuring on deep sea corals and the ones measured in foraminifera. And what we observed, and that was again a very big surprise, is that right at this moment of the younger dryas, we have the presence of a very old, about 1,500 years, a very old water mass coming out of the Mediterranean. This is the water mass which is in its path to exit the Mediterranean. And right at the moment where this disappears, there is again an anomaly of very old waters. And if we frame in the context of the previous records, here we have the neodymium, this anomaly. You're right at the moment of this anomaly, where we were told that more new water is forming in the Eastern Mediterranean Sea. But this water is forming new water mass in the around 900 meters, but this is shallower, are the cores were still on low oxygen. So it means that at this depth, there is a very old water mass which is pumping out as exit. And this water mass, the consequences of a water mass to be very old is that it becomes very, very acid because it accumulates CO2. So one of the factors that we can add to the control, to the development of these deep sea corals, is this change in pH of more acidification water that we believe is the responsible of this disappearance of the corals at these stages. Okay, I'm fine. So I'm going to leave on here. There is many information I have shown, but I wanted mostly to stress that the potential of these different proxies really to understand how circulation works, and they have led us to see that there is a tight connection between this Eastern and Western Mediterranean Sea, but they don't work in the same way. They work in opposite ways. And that's all. I want to say these results are coming from the work of my colleagues. There are some of them, the one in Barcelona, but also part of this work has been developed with colleagues from Italy, from England, from France, from many other countries. Thanks to you for your attention. Thanks very much.
So now we have some time for questions. Actually, I have one question related to the last plot. You were showing there is a tendency, or a very clear tendency, between the measurements coming from the deep corals, but also coming from the foraminifers. But at the end of the plot, there is like a... Yeah. Yeah, so just right there, like close to the line of 14 or 15, yeah, just there. Do you know what is the difference between like why at the end the tendency shows like higher values for the deep sea coral but very lower values for the foraminiferous?
What's the reason? I cannot fully answer. What I can tell you is a nightmare to work with foraminifera in a coral seamount, because the stratigraphy of the foraminifera is completely different of the corals. So we cannot take the age of the corals to transfer that uranium-thorium age to the foraminifera, because as you can imagine, you have the corals and foraminifera settles, and they mix with corals of different age, so they are completely different records. So at the moment to do accurate dates for the forams, we have a trouble. We don't have it for the corals, but we do have for the forams. So one of the reasons can be that there is no actually exactly the same age. That's one of the reasons. And I bet probably there are some other ones, but I think so.
Any other questions?
Probably is, I don't know if I understand well, but when during the younger dryas, the age of the coral is younger than the age of the forams. And this is the same reason? The explanation is because,
no.
Why?
I think we don't know. Okay. We don't know the reason. But I think it might be related to the way that these organisms incorporate the carbon in the shells. And also, the years we are integrating in one measurement on the other. But I'm not sure how it affects, because I don't really understand what is the growth rates of the corals. So how many years we are integrating in that measurement. And also we are not sure about the seasonality when they are growing, if they share seasonality or not. It may be that this anomaly of water doesn't have a seasonal component, and potentially they are not. I think it's related to the biology of the organisms.
Because in theory should be the same age, the same reservoir age, isn't it?
Yeah, in theory it should be the same, but if they are living exactly at the same moment, and the archive is representing also exactly the same period.
Okay.
But we have to keep in mind that always the errors for the foraminifera ages are going to be far larger than for the corals, because we are doing more assumptions in providing the absolute date, and providing the absolute date is controlling the actual reservoir age.
Okay.
So there is a larger assumptions for the ages of the foraminifera. So for me, it's not a surprise that they are not matching exactly the same, because there are many reasons for that. But I think that what is very good that the both of them agree that is a very large anomaly in that period. Yeah.
Thank you.
We still have time for more questions. Do we have, ¿tenemos algo en Zoom? ¿Tenemos preguntas en Zoom? No? Okay, so thank you very much for the presentation. So we are 10 minutes ahead of schedule. I don't know if should we continue or if we are, there is Karen. So we are 10 minutes ahead of schedule. I don't know if because it's people online, if we should just try to keep the pace or just keep going. We can keep going? Okay, thank you. So the next presenter will be Dr. Pietro Bacigalupo from the Università di Milano Bicocca.
Okay, let me. Okay, thank you very much. I would like to thank the committee of the Inqua Mare for this opportunity, and I'm very happy to be here in Costa Rica. It's the first time for me as well. And also would like to thank Isabel Cacho for a lot of things that she explained before me, because then I don't have to explain it in detail. So I'm going to present you a record for some proxy that can testify climate variability between the elastic glaciation and Holocene transition, especially observed through coccolith assemblage and biomarker in the southern Adriatic. So again, like this is the deep sediment core from Central Mediterranean, so the Adriatic Sea. The temporal framework is the last 20,000 years. So again, we're talking about the glaciation, Holocene transition, and our proxy are going to be calcareous plankton assemblage and terrestrial and marine biomarkers. These paleoclimatic proxies register both long-term trends, but also short-term climatic events that are very important in our understanding of the climate changes that occur during this time. Especially, I'm not going to talk about all the climate events that register in this time period, but I'm going to focus on the Heinrich Event 1 and the Holocene rapid climate changes in the late Holocene. So, a little bit of, introduction of this on this proxy. So, the use of fossil record is extremely important because of the tight relationship between organisms and the environment, and especially now we're going to talk about coccolithophores. Coccolithophores, which are unicellular haplophite algae, do photosynthesis and biocalcification, and they are a major component of the marine calcifying phytoplankton, and also they are a major component of they have been and are today major component of the marine carbon cycle. So they are extremely sensitive to changes in the water column, and so they are very good as a paleoclimatic proxy. Then on the marine biomarker, we're going to talk about the alkinones. Alkinones are long straight chain molecular compounds produced by coccolithophores. We don't know why they produce it, but we know that the compound difference in number double carbon-carbon bonds, and this difference, this ratio, is used to calculate the sea surface temperature, and so we can calculate very precise the sea surface temperature in the past. Also, the alkanone concentration in sediment is used to reconstruct organic accumulation and preservation of the organic matter, as we saw with Dr. Caccio before, the sapropel, for instance, sapropel S1 accumulation and of organic matter in the Mediterranean. So then we pass to terrestrial biomarkers, and we're going to focus on analkanes. Analkanes are lipid component of the cuticular waxes of leaf of the terrestrial higher plants, and those these are eroded from land and transported both by winds and river in basin, and so accumulate in the marine sediment where we can find them. The accumulation of these analkanes are used to quantify terrestrial input in a basin. And so therefore we often use the term teralkane to indicate these compounds. Also, the chain length of these compounds is also used to infer the environment on land, because the longer these chain are, the more water retention they do on the leaf of the plants. So if we have arid environment, usually we will find longer chain lengths, and so that we can find in the sediment as well. And the shorter, chain length that we find, we can infer that the environment on land was more humid. So this is our core, the ND14QAR in the southern Adriatic Sea. So again, I'm not gonna go in detail on the circulation of the southern Adriatic Sea, has been explained also in other presentation before. But the main thing that I want to stress out is that the Adriatic Sea is, the heterogeneous input in the Adriatic Sea is mainly controlled by the Po River, which is the main source for land sediments. And and so and it's going to be important for our core. So this is a overview of the SST curve that on the core, on the Adriatic core, and you can see there is a very good, a clear increase from the deglaciation towards the Holocene, at the very good increase in temperature that follow the increase in summer insolation at the same time. Also, we can find that it is very well in line with other records, both in the Adriatic Sea, but also in the Western Mediterranean, for instance, here. This is the Alboran Sea record. And you can see also, so you can see the main trend, but you also can see a lot of up and down, and so a lot of peaks and crevices, and again, that correspond to short-term event characterizing this transition. And I'm gonna focus on the HS1 here, and the Holocene rapid climate change here. So again, a little introduction of the HS1. I've been talking about this in all this presentation, just to remember you that this is an extremely cold episode characterized by ice rafting debris accumulation in the northern Atlantic, reaching up to the Iberian margin. So the HS1 is between 17 and 15 kilo years before present. And so a little bit of nomenclature. So the event is the deposition event of ERD in the North Atlantic, and the stadial is the climatic interval during which this event deposits. And it seems that the Heinrich stadial, it's triggered by a progressive slowing down to a complete shutdown of the Atlantic meridional overturning circulation in the North Atlantic following melting of glacier in both North America and Northern Europe. So the HS1 is composed by several moments, so it has a composite structure, and in the Mediterranean we do not register ERDs, but we do register the effects of the HS1 in the region. In our core, we see that so our proxy register, so we see register a twofold composition of this event, and you can see so A and B. So we have a decrease of reworked coccolith taxa, which are coccolith that are component of the sedimentary structure on land, so sedimentary geology on land, so they are eroded on land and transported in the basin. So their presence can testify of increased turbidity and river discharge in our record. Also, we see this increase in potassium aluminium in our core. So again, potassium aluminium is a proxy of river discharge, and you can see here, so we have high potassium aluminium, high reworked coccolith for testify of high river discharge in this area. And finally, we see this increase in average chain length of the terrestrial biomarker, which again testify of passage from wetter condition to drier condition. So we have a first phase of the HS1, which is more humid, with increased regional input, and then a second phase with increased aridity here. This is also in accordance with other record in the Mediterranean. So we see here, this is the record of Artemisia, which is a pollen of Artemisia is plants that is a steppe plant, so thrives in cold and dry environment. And you can see that there is this very good correspondence between our ACL data, so this increased aridity here and increased aridity in the Western Mediterranean. Yes, so then this is something that I'm very, I think it's very nice. So we have found in this basin the presence of large Emiliana axle, which has been talked by Laura in the morning as well. Sorry, for the first time in the Adriatic Sea, and large Emiliana axle is usually a proxy for, is being used as a proxy for cold moments, but we can see here that yeah, so in the Adriatic core, more than colder moment, it looked like that large Emiliana is associated with the release of fresh water, in this case the two meltwater poles 1A and 1B, so not exactly in line with the HS1 and the Younger Dryas. And so this seems to confirm the this taxon as a proxy for freshwater arrival in the Mediterranean. Then the Holocene, and I'm gonna finish with the Holocene. So we have, again, this is our core, our data, and again it's in very good correspondence with the insolation and also with other records in the Adriatic. But we saw also the presence of these short-term events in the Holocene, and particularly in the late Holocene. These events in the late Holocene are often called Holocene rapid climate changes, and those are a number of short, multi-decade to centennial scale climatic events superimposing over the main trends in the late Holocene. So we have, for instance, in the northern Atlantic, we have the bond events, which are short-term coolings, somehow related to the mechanism that we have shown for the Heinrich stadials. And as Dr. Kachos showed us before, this is in the Mediterranean. We see this increase in deep sea sediment deposition in the Western Mediterranean related to cooling moments and increased deep water circulation. In our core, we see this increase in both reworked coccolith taxa and the Lycosphaera carteri, which are both signals of increased turbidity in the basin, which are well related with this terralcane accumulation, so that testify river discharge. So we have these moments of increased river discharge, increased turbidity, but how we can explain this? These are very well, so this can be related, this moment can be related, this episode of terraneous input can be related with a moment of increased flood activity in the Alps. This is a very nice curve from Wirth et al. 2013 that testify moments of increased flood activity that are related with paleo-NAO phases, negative NAO phases. So NAO is, well, I mean, again, we have shown, someone has showed this before. The NAO is the North Atlantic Oscillation. It's an atmospheric circulation mode. So basically, it's the different atmospheric pressure difference between the Icelandic low and the Azore high. When we have a high atmospheric pressure difference between these two atmospheric cells, we have positive NAO phases with more storms going towards the Northern Europe, and we have warmer, wetter winter in Northern Europe and colder, drier winter in Southern Europe, and the opposite is true during negative NAO phases. So during a negative NAO scenario in the Adriatic Sea, we have increased flood activity in the Alps that translate to increased terraneous input in the basin, which is recorded by our core. So these are the main conclusion of our this study, and thank you for your attention.
Thank you very much. Any questions for Pietro? Yeah.
Thanks for your presentation. Was great. Just maybe a basic question, but how do you recognize this reworked? Is using sediments, the coccolith structure?
We're using biostratigraphy, so basically coccoliths that are not from Holocene, like late places, like older coccoliths from, let's say, Cretaceous or Eocene, Miocene are considered reworked. And also, like, if a coccolith is extremely, like, let's say, broken, more than 50%, so we don't recognize it, it's considered reworked.
Okay, thank you.
No more questions?
Thanks very much for the presentation. I'm pleased to meet you because I think it's the very first time we have exchanged mails, but no.
Yes.
And I like very much your results. I already knew some of them, but the Holocene ones are, well, this story is new for me. And I was wondering, because you showed these very nice pics of the Emiliana Huxley, but I don't remember whether do you have isotopes for this core, or do you have? I was looking for.
We have like some isotopic. No, sorry, for this core we don't have isotopic reference. So we cannot. So we don't have this link. Wait. So we cannot link this with the isotope reference, but if we confront this with other isotopic curves, we can see that those are
okay. But we can talk later because I think I do have
okay,
the isotopes of this.
So perfect.
Okay, so thank you very much for your presentation. And next next we have Herman David Patarroyo from the Unicinos Brazil and Universidad Industrial de Santander. Thank you.
Okay, thank you. Good afternoon. It's me again. The idea with this talk is we don't talk anymore about Pacific. This time I will talk about some results in the Caribbean, this time in the Western Caribbean, and in a place that in Colombia, and actually is called by UNESCO, the Sea Flower Reserve that is located in the Western Caribbean. So the idea is to give some indication about what is the Sea Flower Reserve, where it's located, what is the problematic that we have there, what are the Sea Flower Expedition, that is a national initiative that we have in Colombia, working with this area. And at the end, I will talk about the result that we had collected in this area, specifically in two islands of the archipelago, Alburquerque or Providence. So the first one is, what is the Sea Flower Reserve? The Sea Flower is probably one of the biggest marine protected areas in the Caribbean. It was declared by UNESCO in 2000, I think it's 2001. But I don't remember. It's in the San Andres archipelago. But however, like any island, we have a lot of troubles related, of course, to overfishing, corruption, marine pollution, and I think one of the biggest problems that we have in the San Andres archipelago is the overpopulation. San Andres, that is a part of the San Andres archipelago, is the main island in the archipelago, is probably one of the most populated islands in the Caribbean. So we had a lot of challenges to work in this area. And of course, an additional problem that we have in the archipelago, like any island in the Caribbean, is the vulnerability that these environments had because the hurricane events. And now that we have in a global warming context, these kind of events will be more and more frequent in the time. For instance, this one was in the second island with population in the San Andres archipelago, that is all Providence, and that occurred 3 years ago. So you can see the devastation that occurred in this island. And this one is not the most populated island, so these kind of events eventually, unfortunately, can occur in other parts of the San Andres archipelago. So what we know about the archipelago, actually, we don't know, or we don't have enough information about the ecology of this environment, and of course, we don't have any integration. Of the idea is to have an integration of this kind of data with local community. Okay, so more context about the archipelago. The archipelago is located in this part of the Caribbean. As you can see, it's really close to Nicaragua. Is comprised by 11 islands. Only 2 islands had a population, San Andres and Providencia, and I will present some results about this area, Alburquerque Key, that is the southern insular body in the archipelago, and I will also present some results of Providencia, and maybe I will discuss some results about this island in the northern part of the archipelago. So in general, the geological history of the San Andres archipelago is an history of geological volcanic islands. These islands were developed probably in the Paleogene, in the latest Cretaceous Paleogene. Eventually, they thanks to the coral reef growth, eventually became a typical atoll. And in the case of San Andres, this process continues until the present, with the difference that in Providence we have recurrent volcanic activity in the lime Miocene. So that in general, in the case of the island, okay, In the case of the island, it's plain white. In the case of San Andres, we have the island completely composed of sedimentary rocks. In contrast with Providence, when we have an almost exclusively volcanic island, with the exception of some outcrops that I will show some results at the end. So I will talk about this part of the archipelago. This is Albuquerque Key. It's composed by two small keys. Only this key is populated by some members of the Navy, but in general, only fishermen, local fishermen eventually visit the island. So I will talk now about the Seaflower Expedition. The Seaflower Expedition is an initiative from the Colombian government. It was created in 2015, and it ended the last year by the idea is that we will continue working in the archipelago. What is the idea of these expeditions? The idea was visited each of the islands that comprise the San Andres archipelago, and I will show some results about the investigation conducted in Albuquerque in 2018. So in September of that year, around 20 days, we stayed in the island, worked with several researchers, mostly marine biologists, working with fishes, corals, sharks, some people working with marine erosion and these kind of things. And our research was conducted mostly with foraminifera, in this case with short phase foraminifera for short phase sediments, and we also collected some samples from the reef lagoon with the idea to have an approximation of what kind of ecological preferences have the foraminiferal assemblages in this area. In general, foraminiferal studies in this area are really scarce. We have only a few studies in the 90s in this place of the area, but in general, we didn't have any data about foraminifera in this area. So this is some of the results. With the difference of the study that I presented this morning, in this case, we were able to collect living assemblages. So we were able to collect around 27 genera, 46 species. Some of them were symbiont-bearing foraminifera, and this is important because in general the symbiont-bearing foraminifera share the same ecological preferences of the corals. So I will explain why this is important. But in general, we found the typical foraminiferal in reef environments: Archaeas, Amphistygiana, Cymbaloporeta, Rutarminella, etc. And we have some differences between the samples that we collected in the North Key, or the South Key, and around the reef lagoon. As I said, in general, assemblages are typical from a marine lagoon, hypersaline lagoon, so they were dominated by porcelaneous taxa, hyaline forms, symbiont-bearing forms, so it was something that we were expecting in this area. And something that eventually we tried to test with statistical analysis was try to relate the assemblages between the each keys and the real lagoon, and we found that in general the real lagoon assemblages share more similarities with at least one of the keys, not with both keys. So maybe that was related with local currents, but it's something that we need to explore in the future. So what is the idea in this area? The idea was using also the foraminifera to make ecological assessments. So we conducted this index that is really common in this kind of environments, developed by Pamela Hallott and colleagues in the University of South Florida. That is the Foran Index. The Foran Index was explored the proportions of foraminifera, of symbiont-bearing foraminifera, the proportion of, for example, stress-tolerant organisms, and some other data that they don't care actually if the environment is good or bad. So What is the idea with the foreign index? In general, when this index is go from 0 to 10, with higher values indicate or suggest a really good condition, environmental condition for roof. When you have values in this between 4 and 6, you have some kind of stress, and in general, when you have really low values, you have some kind of stress. So in general, the data we collected in Albuquerque is these red points. We also have another additional data from all Providence and other islands, and these other dots are came from previous data. In general, but the idea was to present or to conclude that we had good conditions in Albuquerque. That is something that agrees with some surveys, ecological surveys conducted with corals and fishes. So that proves the potential that foraminifera may have for conduct this kind of analysis in other parts of the archipelago. And one of the areas when we are now conducting analysis is with material from all Providence, that is one of the populated islands. And in this case, we also took advantage that we have some outcrops, in this case, the Miocene outcrops in that island. So we now we are conducting some basic geological surveys in this area, working with the petrographic material, trying to conduct some micropaleontological analysis. And also, these results were recently published. We also work with macrofossils. What is the idea? The idea is try to improve the paleoenvironmental reconstruction that some authors have proposed for San Andres, that is the more popular island, and all Providence. These paleoenvironmental inference had been conducted with coral, so the idea is try to improve these previous models using, in this case, the fossil foraminifera. And yeah, and this is I think this is the main idea with the research. So something I forgot to mention is that these results that I mentioned of Albuquerque will be published. I think that in a couple of weeks, we'll be able to in the Journal of Foraminifera Research. So yeah, and I would like to thank all the organization, especially to Comisión Colombiana del Océano, that is the committee that is in charge of this research expedition, and of course, thanks to another institution that participated in the expedition, and also thank you to Inqua Mare for the invitation. Okay. Thank you.
Thank you very much. Do we have any questions?
Thank you for your presentation. I have a curiosity about your, how do you sample the recent sediment?
Okay. Actually, it's quite simple. The idea is only to collect. Actually, I use this kind of, I don't remember the name. It's a kind of a graph that people use for collect excrement of dots. So I only.
So you don't know how much, which is the width of the sediment,
okay.
and the age, of course.
Yeah.
If you take only the recent or
no, there is a mixture. For instance, I am aware that I can use, for instance, for making this ecological approaches like the foreign, I can use this index in samples that were collected in the shore phase, because you have this kind of reworking. So one of the recommendations when they use, when the people use this kind of index is try to avoid this kind of material and working exclusively with at least the 5 centimeters. I think is the ideal for this kind of material. But in general, the first 5 to 10 centimeters. I am aware that I had some methodological biases in this kind of research investigation, but considering that it was the first time that we collected material, I think that it worked for now, but eventually I had to improve this kind of issues.
Thank you.
Thank you. Okay. So we have the last presenter before the coffee break, and it's Dr. Komal Chinde from the Belore Institute of Technology. Thank you very much.
Hello. Good evening, everyone. I am Komal Shinde from Belore Institute of Technology, India. I am pursuing a PhD under the guidance of Dr. Mohan K. So today I am going to talk about the response of past climate from the Bay of Bengal to the regional monsoon and the global climatic events since the 33 kilo years before present. So moving to the introduction, so since morning you guys have heard about the Indian monsoon, and so the Indian monsoon is one of the powerful and dynamic circulation system which brings the because of the seasonal reversal winds changes, and which is manifested by the intertropical convergence zone to the movement of that zone into the north and south over the equator. This Indian monsoon is responsible for the society, then economic, and directly and indirectly to the land uses over the Indian subcontinent. It is also the major source of the fresh water, not only for the India but the nearby countries also. The Bay of Bengal is the one of the region which is the largest bay in the world, and it receives the huge amount of water like the largest rivers like Ganga, Brahmaputra, Krishna, Godavari, and these water debouches into the Bay of Bengal during the southwest monsoon and the northeast monsoon. And it brings this water brings the high stratification during the southwest monsoon, which from the peninsular regions of the India and the Himalayan terrain. So this brings the high stratification, and during the northeast monsoon, it is due to the less stratification and cold and dry winds. It gives the intermixing vertically, and it makes the Bay of Bengal potential for the despairing the paleoclimate changes. This monsoon climate of the Bay of Bengal requires extensive studies. Since the dominance activity of the human, since last few decades, the much study is done to reconstruction of the climate and its relation with the natural forcing. Still, the response of the low latitude or the tropical climate in terms of the global events remains scary. The one of the reason behind of it, the restricted resolutions of the spatial and temporal. So it needs to be improve this resolution. So here it is then only we can try to understand the more paleoclimate responses towards the regional monsoonal and the towards the global events. So this is my study area. So study area SK3360C2 is the gravity core, is retrieved from the water depth of 814 meters. It is spread of the Visakhapatnam of the south west coast of the Bay of Bengal, and this reversal wind directions we can see here the southwest monsoon currents with the red, and the black current is the indicating the northeast monsoon, which is the seasonally changes. So this core is totally 5.56 meters, and the coordinates is given here, and totally 343 samples is retrieved from this core. The standard procedures is used to for sample processing, microscopic analysis, and the census count was done for the plantic foraminifera for this study. The Plantifera minifera, as we know, it is one of the very sensitive to the climate, and during their seasonal changes is easily get captures into their shells during their growth, and therefore their ecology is very helpful to delineate the past climate changes. The species which is more than 5%, it is used here as environmental stresses. So this graph is showing the Plantifera minifera species plotted against the age, and the vertical, the color bar is indicating the geological events. So these species like Globigerina bullaidis is a cold water and a subtropical species which is associated with the tropical upwelling. It's showing its high peaks during the some like 32 kilo years to 27 during the LGM period, and 80.5 and 6 and 4 kilo years. So on the other hand, the species like oligotrophic species like J. ruber and the Tralobatus saclifer, is the low nutrient prefer and the warm water species. It is showing their high abundances during the 33 kilo years, then during the boiling yellow rod period, and there are some like 0.35 and some the periods which is like showing the high warm environment. So the species where the endutatory, the species is show majorly find with the fresh water and also the upwelling. So it is showing during the last glacial time, it is showing the similar trend with the G. bullaidis, which is indicating the upwelling and intermixing of during that time period. But during the Holocene time, both the species are showing the almost the opposite trend, not the simultaneous trend, which is indicating the fresh water and the high period of a monsoon during the Holocene. The warm water and thermocline G. menardis species here, it is showing the less appearance during the last glaciers, but the high appearance during the Holocene, which is indicating the warmer Holocenes. So this for some more, the proxies is used here like a mixed layer oligotropic species and the mixed layer eutropic species to understand this data. So here we have seen the high abundance of the oligotropic species and the low abundance of these eutropic species are showing opposite trend almost. So during the oligotropic species during this time period of 30, 28 and boiling yellow rod period and 6 to 4 kilo indicates the low productivity, which is indicating the high stratification, and the high stratification is just because here in Bay of Bengal, because of the intense southwest monsoon, which brings the enormous river flux into the Bay of Bengal. While the eutropic species and the G. bullaidis and G. ruber ratio is showing the good amount, the good abundance in during the 32 to 27 and 19 to 20, 16, 8.5 and 1.2 kilo years, which is indicating the high productivity, and it is vertical intermittent mixing, and which is possible because of the low stratification. And the high magnetic values are is observed during the Holocene period, and it is signifying the stronger southwest monsoon during the Holocene. So in this study, we have observed up to the 5,000 kilo year, the high resolution data. So the climate variability is changing rapidly during this time period. And therefore, it is observed that the 6 phases of the climate changes here, where the warm phases is observed in the first and the third period, which is showing the poor vertical mixing, and the stratification must be the high. While the 5th and the 6th is not, the species are moderately abundant in these phases, which is indicating the stable monsoons. And the phases 2 and 4, which is indicating here the productivity is enhanced and the low stratification, which is supported by the mixed layer oligotropic, and the faunal proxies is given here. During the this period, it is also observed the adopted as this as an ongoing study. It's, the isotopic data is not the result came. So the nearby study of the Govil et al. Is this data is adopted, and this also it is observed that the during the period of the Holocene, this the monsoon was comparatively higher, and during the younger dryas, the solar insolation is also bit higher. Therefore, the gibulides is not showing that appearance, and the younger dryas was not that colder at this in the Bay of Bengal at this region. So, by observing this study, it is seen that the proxy record suggested that the present site appears to be linked with the changes in the Indian monsoon intensity, and however, it also shows the response towards the regional and the abrupt global climates. The periods of a strong monsoon with the boiling yellow rod and the Holocene are characterized by the high value of concentration dependent magnetic succibility parameters also supporting for this. So in this study, the gibulides shows the significant results during the last glacial monsoon, last glacial maximum, which is indicating the eutropic and nutrient condition and the colder region. But it is during the younger daya, as I said, the event doesn't show that prominent abundances over there. So the present study is help to decipher the colder climate changes into with a higher resolution during the last 5 kilo year before present. And overall, it is also suggesting that the changes in the pattern of the monsoon of southwest and the northeast, it regulates the hydrography and the productivity. So I would like to thank for this opportunity to me here, and
Thank you very much. Do we have any questions?
Thank you. It was very, very interesting. I was wondering, it's more a curiosity, have you tried to relate this foraminifera proxy with like terrestrial proxy, let's say pollen or something like that, to infer humidity and aridity variation on land?
no, up to it, I have not tried that. The terrestrial things I have.
Okay, thank you.
Anything on Zoom? No? Okay, thank you very much. So how should we proceed? We were supposed to take a 20-minute coffee break and be back at 4, but I think we can also come earlier, right?
Yes, we can.
Okay.
We can start with a coffee break.
Mm-hmm.
Before the thank you, Celeste. And before the coffee break, a little bit of information. So first of all, during this coffee break, please reach out to Viviana and ask for your ticket for tonight icebreaker party. I hope by now you have decided whether you want a beer, a cocktail, or a virgin cocktail. And the other thing is, please, the person that are going to present tomorrow, if you can send me your presentation by tonight so I can organize a folder for... Okay, Mark, don't laugh. And I guess that's it. Okay. Yes, of course. The icebreaker will be at the Sanko Bistro, but we will go together. However, I think you should have had the instruction to go there. Okay, so if you want to go there by yourself, you still can, but we will go together. Okay. So you can go and have your coffee. Go. Be back at 4, right? Be back at 4. Ciao Carolina, ti vedo.
Excellent.
Aspetta solo un secondo che vado a chiamare il tecnico, eh.
Vai, vai. Io ti sento, eh? Sì, sì, te mi senti? Te mi senti? Allora, bene, bene, voi tutto bene? No, vabbè, mi immagino organizzare una conferenza, mi posso solo immaginare il livello di lavoro. Ah, giusto, allora... share screen, questo qui? Sì, share screen e poi... Boh, vabbè, per ora faccio il desktop, vai. Poi la prossima volta... Sì, sì, questo, boh, l'email. Ok, va bene. Allora, aspetta, lo rilevo. Ah, no, figurati. Fatto bene. No, non ci ho fatto caso, ero di là e non me l'aspettavo, ma... No, va bene. Allora, rapidamente, quindi io mi connetto a questo indirizzo poco prima della riunione e poi mi chiamate voi per la presentazione. Basta, diciamo, che io rimanga connesso. Ah, sì, me lo sono segnato, ho messo, ehm, io ho messo alle 16:40, sì, l'11, giovedì, giovedì l'11, ok. Ah no, molto rapidamente ti volevo chiedere, secondo te, perché ho visto che nella presentazione hai messo opportunità di internazionalizzazione a Pisa. Ora, vuoi che faccia come l'altra volta? Io l'altra volta quando era in Inqua Mare a Pisa avevo parlato un po' di tutte le opportunità e essenzialmente anche sì, dei benefici, però dimmi te esattamente cos'è che ti interessa, perché 20 minuti sono anche tanti per la presentazione in genere che faccio io. Ok. Vabbè, faccio quindi quella dell'altra volta che feci a Pisa quando va bene sempre. Ah, ok. No, però ti dico, ci sono tanti accordi quadri, ce ne sono tantissimi e vengono firmati a bizzeffe senza problemi perché cioè, non comportano nulla, cioè non c'è soldi, non c'è cioè sì, ok, magari qualora tu volessi fare una visita c'è un accordo quadro dietro per cui puoi usare questo come titolo se hai bisogno, però poi se soldi non ce ne sono e non ti pagano, accordo quadro, non accordo quadro, che cazzo vuol dire? Cioè, ci vuole, cioè, capisci, è quello il problema. Va bene. Ok, d'accordo. Allora divertitevi, salutami tutti. Ciao bella, ciao.
So, welcome back. Now we are going to have these speak talk sessions. So we are going to have 4 presenters, and each of them will have 5 minutes to present their topic. So first one is Alexis Rodriguez Jimenez from the University of Costa Rica.
Good afternoon for all. I will talk to you about a very long work that we do with radiolarians from the Pacific Ocean. The poster comes from a project, a macro project from the University of Costa Rica, in collaboration between the CIMAR and the SIG, that studies all aspects of the geology in these sediments. We use 13 cores recollected by Rock Hits Expedition and Costa Rica Deep Sea Connections Expedition. The poster itself results from a taxonomic investigation on the radiolarian remnants in the sediment sediment cores. The age range in the Ocean mainly. There is not exist a taxonomic catalog for the radiolarians in sediments for Costa Rica. This is the first effort to create a catalog for future studies in the radiolarians that have importance in paleoceanographic studies. The taxonomic that we used is the classic scheme of Riddle from 1971, with some modifications with respect to new investigations in the area and the taxonomy adopted by the World Register of Marine Species, worms. The main section of the poster is a display of the taxonomy group for the class Polycystina with the 3 classical orders, order Colodaria, order Spumellaria, and order Nacellaria. We use the families that we identify for each order, and each family has a QR code that displays the species observed for that family, like like this plate. That counts with an image of the organism in SEM image or in light image, depending of the necessity for identification of the organisms. This is all. Thank you for your attention.
Perfect timing, 3 minutes. Okay, so next is Maricruz, Valverde Valdez. She's also from the University of Costa Rica. And in this case, we are not taking questions now, but we are going to have like a question session afterwards in the room with the posters, so you can also ask questions there.
Okay. Good afternoon, everyone. My name is Maricruz Valverde, and I'm going to talk a little bit about our investigation. It's about exploring the biodiversity of benthic and planktonic foraminifera in the Pacific south of Costa Rica in superficial marine sediments. We analyzed the first 3 centimeters of 7 different sites along the platform, the marine platform, and we tried to identify the main species of these different benthic and planktonic species. Okay, here you can see the abundance of each benthic species and the geographical distribution of these forums. The principal species that we identified were Bolivina interjuncta, Bolivina striatula, Uigerina incilis, Trifarina angulosa, and Gyroidina rothwelli. The same thing with the planktonic foraminifera. In this case, we can also see the abundance and the geographical distribution, but in this case, we have Globigerina uloides and Globigerinioides ruber, with also Globigerinita glutinata and Neogloboquadrina utertrei and Globorotalia menardi and Globorotalia tumida. And yes, that will be. Thank you.
Thank you, Maricruz. So next it's Anna Pienskowski. Sorry if I didn't pronounce it correctly. So Anna, you have 5 minutes.
Thank you very much. I'm very happy to be here. First time in Costa Rica, and I will never leave. It's so nice here. Today I would just like to draw your attention to my poster, which you can see in the poster room, and which is basically an introduction to a new research project that is funded by the Polish Research Council. And I am based partially in Poznań in Poland at Adam Mickiewicz University, and as of 3 months ago, we've had this project funded with colleagues. I'm the principal investigator, and its focuses on the Holocene thermal maximum as a kind of roadmap to a future warmer Arctic. And the short name is Aphrodite, which is very lofty, but it's basically Arctic Paleo Records from the HTM, a roadmap for imminent transitions in marine ecosystems. Deep breath. But it basically aims to understand or to advance our understanding of how polar marine environments as well as ecosystems develop under climate warming. And it does so by providing a very comprehensive pan-Arctic parallel from the Holocene thermal maximum, which is the most recent period of warmer than present global climate. And we all know, I think this is kind of preaching to the choir, but we all know that climate change is progressing fast, and it is probably the Arctic, as well as the Antarctic, but especially the Arctic, where we see these changes happening very quickly, very rapidly, and in terms of assessing how these changes will progress and how environments change, but also then ecosystems change, is very difficult because we have a very short observational period, and we also have very many discrepancies when you look at model-based projections. And especially if we look at different ecosystems groups, we often have this kind of assessment of mixed effects, so both positive and negative. So what Aphrodite is trying to do is to focus on this parallel from the past as a roadway to a roadmap to the future. And as I said, we're interested in the last warm period, the Holocene thermal maximum, which was a global period of warm climate, but most evident in mid and high latitudes of the northern hemisphere. And of course the driver was a bit different than what we have today, which is greenhouse gases. Back then it was orbitally forced summer insolation, but still we have this really valuable past parallel. Thank you. I will use all my 5 minutes. And so focusing on the HTM, and not just in terms of having a pan-Arctic understanding of those changes that we see in the marine environment and marine ecosystems, but also with a concerted same methodology, chronology, and so on. This is the kind of plan. These are the cores that we have selected. So most of what we are studying will be based on existing cores that span the Holocene thermal maximum and that have already some radiocarbon chronology. There is, as you can see, a blatant gap in the Russian Arctic, but there may be some ways to get some material from colleagues in Germany and so on. So we're exploring that at the moment. If you want to know what we're really doing, like specifically, it's a multi-proxy approach. We're going to be using a lot of different proxies that we actually talked about today. For a minute, oh my goodness, 1 minute. So microfossils, sedimentary DNA, biomarkers, but come and check out the poster because I think we can talk more about it. As I said, funded by the National Science Center in Poland, and there will be 1, potentially 2 postdoc positions announced shortly. So watch this space. Come and see the poster. Thank you.
Thank you, Anna. And finally, we have the last one is a pre-recorder presentation. And after that, we can move to the poster room.
Hello, I'm Jen from the Earth Observatory of Singapore, and I will be presenting the poster Coral-Based Mid-Holocene Marine Reservoir Correction for Singapore. Accurate marine radiocarbon ages of coral or marine shells, for example, require knowledge of the marine reservoir age, which is the offset between the apparent radiocarbon age of the ocean and the atmosphere. This offset between the oceanic and atmospheric carbon reservoirs is known to be spatially variable, but it may also change over long or short timescales. In this work, we will calculate the marine reservoir correction through time using a series of paired radiocarbon and 230 thorium ages, also known as uranium-thorium ages. We collected our samples from fossil coral microatolls near Singapore's southern islands. We only use samples that contain less than 1% calcite, as measured using XRD, no evidence of open system behavior, replicable radiocarbon ages, and relatively low detrital thorium concentration to minimize the uncertainty introduced to 230 thorium dating by a non-radiogenic source of thorium in the coral. Marine reservoir correction delta R appears to vary between -300 years and 0 years, with a possible rapid change in magnitude at 7.4 thousand years before present. The choice of software used to make the calculation does not affect the mean value of delta R. There is an additional uncertainty associated with the unknown true initial 230 to 232 thorium ratio, even for samples with relatively low detrital thorium concentrations as used in this study. Nonetheless, the broad trends in delta R do not depend on the initial thorium ratio that is assumed. If you have any questions about my poster, feel free to reach out to me. I'll be happy to discuss. Thank you.
Okay, thank you very much to all the presenters. So with that, we conclude our day of talks. And now we can move to the next room where are some posters, and then we can just take the space to discuss in more detail with the presenters. Thank you.
We have sent to you the link to My Networks, which is the platform where you can find all the posters, also of the person who are not present here. So please join it. back the link tonight, but please join it so you can comment all the posters. Okay? Thank you. Okay, and I will call you up when we have to move to the ice. What time are we going to the icebreaker? In 45 minutes. Okay, in 45 minutes we will leave for the icebreaker.